Hey everybody, this is our second video related to slope. I hope everybody got a chance to watch the first video. So let's do a quick review of what we saw in the previous video. We saw that slope is literally walking the line. We talked about slope as being rise over run. And so if I wanted to walk the line that I have here from the leftmost obvious point to the rightmost obvious point, I'm literally going to walk rise over run. In this case, the rise is going to be downward because this is a decreasing line. It's tilted down. So I'm going to be walking down 1, 2, 3, 4. And I'm going to be walking to the right 1, 2, 3, 4, 5, 6. So that tells me that I have a rise of going down 4, which I know I show by a negative number, and to the right 6. I can simplify -4 over 6, and that becomes -2 over 3. That tells me that I should also be able to walk down 2 and to the right 3 to keep connecting to the line. So let's see if that works. I should be able to go from here and walk down 2 to the right 3 and still hit the line, and I do. And I should be able to continue doing that. Down 2 and to the right 3, and I would still hit the line. And that pattern should continue the whole time. But what's different in this video is that now we're going to go a little bit further with what slope means. So let's go further with rise and run. Slope, we know, is rise, which is also walking in the vertical direction. That's what rise means. So this is a change in the vertical direction. Over, we know that it's run typically, but run is, we know, horizontal because we go from left to right. And so this is a change in the horizontal direction. All right, so far that wasn't too much of a leap, but now let's look at it in terms of our graph. The vertical direction is along which axis? The vertical direction is the y direction. So we can go a little bit further with this idea and say that slope is the change in y divided by the change in x. Now, I don't want us to get so connected to x's and y's because it might not be x's and y's all the time. So this is also the change in output divided by the change in input. So hopefully we've been going step by step here, kind of building on what we're noticing about slope. Last but not least, we have to look at the word change. The word change is a mathematical word as well. Change is a subtraction word. And so we can think of slope as the difference between two y values, y2 minus y1, divided by a change in two x values, x2 minus x1. Why do we have subscripts here? The subscripts are only here to show you that this x2, y2 has to come from the same ordered pair. And this x1, y1 has to come from the same ordered pair. That's the only reason that there are subscripts attached. You have to make sure that you're going from the same point and walking to the constant other point, okay? So the x's and y's have to be coming from the same point. So now let's go in and do this a different way. This ordered pair is the point -4, 3. And this ordered pair is the point 2, -1. And we're going to call this x1, y1. And we're going to call this x2, y2. And I'm going to encourage you to label your ordered pairs, especially for now. This way you can just use this as a direct substitution. If I now substitute what I labeled y2 and y1, I'm going to be plugging in -1 minus 3 over, and if I substitute my x2 and my x1, it would be 2 minus -4. And now let's do the work. Minus minus, we know two negatives become a positive. So minus minus becomes plus. And look at what we get. We wind up with -4 over 6, which is the same thing that we got when we did rise and run, which simplifies to -2/3. So we discovered that we have a shortcut formula for slope. Let's do it with this other graph that I have here, except this time we won't do the rise and run. We're just going to jump right into this formula. This is the ordered pair 1, -3, and this is the ordered pair 4, 3. If I use this new concept of slope as y2 minus y1 over x2 minus x1, first let's label. I'm going to call this one x1, y1. I'm going to call this x2, y2. Try it going the other way if you want. You will get the same answer. So it does not matter which one you label x1, y1 and which one you label x2, y2, okay, as long as you are consistent. If I now do my substitution, this will be 3 minus -3 over 4 minus 1. We know again, minus minus becomes plus. And so this is going to give us 6 over 3, or simplified 2 over 1, or just 2. Fractions are our friends when it comes to slope, because slope itself is a fraction, rise over run. So I could always just put the number over 1 and use it as rise over run if I wanted to walk it out. So let's see if this 2 over 1 is how we walk the line. So let's come back over here and walk from left to right. If I start here and go up 2 to the right 1, I do in fact hit the line. Up 2 to the right 1, I still hit the line. And if I continued, I would still consistently hit the line. So I know that that is the correct slope. If you wanted to go back and just count out, just like we did in the very beginning, how to get from here to here, I would have to go up 6 and to the right 3. And so that's where we originally get our 6 over 3 from. So this slope formula will be a shortcut now that we know it. So we built this shortcut, okay? That means that we don't need a graph to be able to use it. So what if the problem said, find the slope of the line through -4, 3 and 2, -9. I don't have to plot these 2 points and count it out. Now I have the slope formula. So slope is y2 minus y1 over x2 minus x1. Let's label them. I'm going to call this one x1, y1. I'm going to call this x2, y2. It doesn't matter if you called this x2, y2 and this x1, y1. As long as you label them consistently, you're going to get the same answer. And now let's do our substitution. This is going to be -9 minus 3 over 2 minus -4. We know that minus minus becomes plus. And so this gives us -12 over 6, which simplifies to -2 over 1, or just -2. So I'm able to still calculate my slope. For note purposes, let's put this all together now. First of all, we are now going to call slope by a letter. We're going to call slope the letter M from now on. M is going to represent our slope. So M is our slope, which we first saw as rise over run. But then we saw that rise was really a change in the y direction. And run was really a change in the x direction. We know that change is really a subtraction word, and that's what got us down to y2 minus y1 over x2 minus x1. So now we can just go right to m equals y2 minus y1 over x2 minus x1. And we can go straight to that formula now to use as slope. All right, let's do 2 more examples for this video. What happens when we have a horizontal line? What happens to our slope? Okay, so let's put the tick marks in. 1, 2, 1, 2, -1, -2. Okay. Let's say that we're going to walk the line and we're going to pick this point and we're going to pick this point. Okay, and now as we've seen in the other examples, the points we pick don't really matter because we're just going to be walking the line. It's going to come out the same. So if I wanted to go back to our old definition of rise over run, the original definition, walking the line, I'm not rising as I walk from this point to this point. There is no rise. I don't have to go up at all or down. And so my rise is 0. My run is 1, 2, 3 in this case. But what's 0 divided by anything? 0 divided by anything is 0. So now I just saw a very important rule. The slope of a horizontal line, which we saw earlier, is also called a constant function, is 0. That's going to be true all the time. Now let's take a look at a vertical line, which we know is not a function. So let's say that we have a vertical line going through 3 on the x-axis. And I'm going to go through this point and this point. This time, let's do it with our new formula. We know that this is the ordered pair 3, 2, and we know that this is the ordered pair 3, 0. And let's call this one x1, y1, and let's call this one x2, y2. So if I go to our formula for slope, m equals y2 minus y1 over x2 minus x1, and I do my substitution, this is going to be 2 minus 0 over 3 minus 3. And when I calculate that, it's going to give me 2 over 0. I have a problem. Am I allowed to divide by 0? We learned that 0 is not allowed to be in the denominator. If you have 0 in the denominator, we call this undefined. It cannot be done. We use the word undefined here. And so that lets us realize another fact, that is the slope of a vertical line is undefined. This is important to note because you do not have to memorize these facts. I think it would be a good thing for you to know them, but the work getting there is also not too difficult. Okay, so the work that we showed to prove that the horizontal line had a 0 slope and to prove that a vertical line had an undefined slope was really just going in and calculating the slope. So if you have to do that, if you forget which one is which, you can easily go in and still do the calculations. So I hope this video makes sense. Again, contact me if you have any questions, and I will make the next video shortly.